Hey guys, today we'll be solving essentially stacks and queries. I'll be going over five questions actually, and be solving them in order, and they are easy through hard, and the primary focus will be on stacks for the main focus for today's topic will be stacks. A quiz just because you will cover them in BFS later, and the idea behind a quiz is pretty repetitive to everything else. Like a circular list is something you could think of as a queue, right? A stack, on the other hand, it's not that easy to identify that this is a stack question. That's why I picked stack a bit more than quiz, and we would go over them in our graphs as well, quiz in particular. Alright, valid parentheses. We've been given essentially this set of parentheses, right? They can give us any of these three, right? And the only edge cases that you really need to worry about is the fact that you open with, let's say, a circle and you close with a square. That's invalid, right? Or if you just open and you don't close it, that's invalid. If you just close it, that's invalid, right? So there's just three cases where it's really just invalid, and there's one case where it is valid. Let's say, let's do a bigger example, something like this, where you open it with a circle, you close it with a circle, you open it with a curly, and you close it with a curly. This would be a valid one, right? And the logic in this code, it's pretty much just going to cover that, the invalid cases. That's what we really care about. Now, there's a couple of ways of doing this, but I found the best way to do it is to have a dictionary, right? You can call it a dictionary, you can call it brackets, whatever you want. And this way, I essentially use this. So whenever I encounter an open one, right? Whenever I encounter an open one, I know the corresponding closing one. So if I do have, let's say, a string that goes like this, then the next element that I will check will be this, right? The second part. So I would know based on this, like, hey, this is the appropriate closing one. Although this won't really be, like, I won't be using it this way. Like, I won't be using it to compare value by value. I'll be using the key in order to get the value, and then I'll see if it's closing. I'll just explain the I'll just go through with the code. You'll see it a lot easily when I do that. What we do use though in this question is stack. Stack being life or structure. Last in, first out. Whatever you put in, the last is the first thing that comes out. You can think of it like a container, right? Let's say you put 1 inside the container, you put 3 inside the container, you put 2 and 3 inside the container. The first thing that you will take out is 3, right? You can also imagine it as a sticky note, right? You place on top of his sticky note, and then the first thing that you take out is like the first sticky note, right? That's just stack in a very visual sense, right? Now, we'll go through the string that's given to us, right? Okay, if I saw this in my dictionary, then I'll just simply append it, right? Because we don't really care about it being invalid right now. What we care about is just setting up the fact that we've opened X amount. We'll get to the main emphasis is just the closing part, right? Like I said, the only part where it can be invalid is where you close in the wrong way, or you leave something open or closed. Now, if we did else is essentially the cases where it is this, right? Because every other case would be coming here. So else is this case. And if we just close without any elements, like there's no openers, then immediately we know that this is false, right? I've already given this as example number 3 over here. Next, now what does this line do? So si is the closing, right? And this way stack -1 will be an opening, right? And the value of that opening will be a closing, right? So this essentially checks if I was given this previously, and if I put this, is this equal to the, like, is this si equal to the value stored in the dictionary? Essentially just checking the closing part. If it is, if it isn't, sorry, if it isn't, there's a not equal to you. If it is not, then you know that is false, right? But if it is, then well, just pop from your stack because you've closed it, right? So if you can imagine, let's say, yeah, I'll just do the first example again. We check this, and then we would pop both of them off. Then we would check this, and we would pop both of them off, just like that. Now, if there's something in the stack still remaining, that means you probably give me something like this, right? So that would just be return false. That's example number 2. And return true if all the other checks fail. You could also just do return stack equal len stack equals 0. That's completely fine as well. Alright, moving on to the next question now. Actually, I'll show this one last time. It looks something like this. Right, moving on to the next one. This emphasizes queues. In Python, we use the dequeue module for this kind of questions. And in this question, we've been told, essentially, right, every student picks 0 or 1 as their sandwich preference, right? And you can imagine a canteen lady, the sandwiches that are available with that lady are 0 or 1, right? And given two lists, let's say 1 1 0 1, 1 0 1 1, this is sandwich, this is student, right? If you're given this, then there's equal matches. Every student will get their own sandwich and they will all move out of the queue, right? But in the case where it isn't equal, this student is very considerate. He'll move all the way to the back, right? Yeah, and he would push everything else left. So it will now look like 0 0 1 1 0 0 1, and then we would see these two match, pop those two, 1 0 1 1. This guy does not see it, he goes all the way to the back, comes all the way, and then we would get 1 1 1 0, and we would see that this would essentially be stuck in a loop, right? Because now no student can get their sandwich. Like, the only ones who can actually take it are the ones at the very front, right? You can't match these two, you'll take it at the very front. So this essentially just creates a cycle, and I'll show you how we detect the cycle. And in this case, we would return 2 as the number of students who didn't eat, right? Okay, so let's get to the question immediately. What I did was I made a dequeue on both sides, just so it's a lot easier to pop. Now, how did I... Okay, so I'll just show a variable right now. You can ignore it for now, okay? Whatever I write related to that variable up until the very end, you can ignore it. I will show you the reasoning behind this variable very quickly. Okay, like I said, if we do match, right, if the two match, then remove both of them from their respective queues, right? Now again, ignore the variable for now, just ignore it. Now if it doesn't, like the preference doesn't match, right, the student will go all the way back. So I'll pop him, right? I'll pop him and then I'll just append him to the very end. Append does it at the very end, pop left pops from the very first row. Okay, let's see. Right. This question, what did I use the counter for? So let's consider this example once again, right? 0 1 1 0 0 1, right? It's a very good example actually. Counter equals to 0. This essentially is like a flag, right? This flag helps me determine when I should stop looping. Like I said, we just had an infinite cycle right now, right? So how do we know when to break out of that cycle? Well, this variable is the thing that will help us flag that. 0 0 1 1, right? We see this, we match them, we pop it off. Counter remains 0, right? I'll actually write down a table here. Counter remains 0, right? First iteration. 1 1 0 1, right? We see this one, we move it all the way to the back. Counter plus equals to 1 happens, right? In this case. So counter now becomes 1. Then 1 1 0 1, right? Because you've shifted everything left, you'll see this one again, no preference. So comes down like that, 2, right? Now, what was the length of ST, right? That is 3, right? So we're getting very close. Now we'll do one more loop. No preference matched, so go back around. This time it will turn to 3, right? And essentially we've done enough passes, right? We've done a singular pass, right? Essentially what we've done is a singular pass through the array, shifting all elements and seeing if none of them are matching, then we know that it's pretty much impossible to actually get anyone to get their sandwich. Hence, that number of students will go hungry, right? And that's pretty much it for this question. So at the end, you just return whatever your counter was, right? Sorry, also it won't be 3. It will break off at 2 already, because len st would end up becoming 2. It is a modifying attribute. Maybe I should actually, for better practice, make it an n variable. No, actually it should be modifying. Yeah, okay, leave it like this. Len st equals to 2, because it gets modified in the string, right? So when you do hit 2, you've already done a full iteration like I showed, and that would cause it to pop. You would come down here and this would return 2. That means 2 students were unable to eat, 2 being these. So this is the correct version. Sorry for that. Now we'll move on to simplify path. This one's a bit of a syntactic thing. I mean, for me it was a syntactic thing. I didn't know that what we use, right? Oh wait, actually I'll explain the question first. In Unix, when you do cd, right, the change directory, you're usually given a lot of options. You can change into a specific one. You can give like a name, right? You can give dot, you can give dot dot, you can give this, right? Just ignore everything else that I've said after that. But over here, what do we care about? Name, dot, and dot dot, right? cd name allows us to go into that directory, right? cd dot stay wherever you are, stay, doesn't really matter. cd dot dot, on the other hand, go back 1, right? Now go back 1. What, like I just said, right? Sticky notes. What did we do with that? Let's say you did cd name, you went to some directory, and now you want to go back. right? You've put all these sticky notes on top, you've gone to this directory, and then you want to pop that sticky note off, right? I've hinted at the data structure we would use for this. It is stack, right? Because all we're doing is going into a directory and then popping it off. Okay, so there's only the dot that matters, right? The syntactic part that I was talking about, it's the issue that comes with Python a little bit. I actually didn't know this until I went into the visualizer myself. But whenever you perform a split, I mean, I will split with the slash, right? Because they've given to us slash home slash onwards. It's very easy to just do it with the slash so that you can get these parts in the way, and then you can just join them later with that as a separator. But the thing is, when you do encounter these slashes, right, Python, when it does split on them, it will turn it into an empty string. Now that's a bit of an issue that I didn't know about at that time, and I was writing code with if statements for that, but it turns it into an empty string. And it does this for the other aspect of the question as well, where if you're given 2 or if you're given like 3 or even more multi-slashes, Python will still convert all of those relevant things into these empty strings, right? It will do it in the multiple of whatever x that you've done, like the amount of slashes. And that's the only syntactic part of this question. Besides that, it's relatively very straightforward actually. So I just look through the names, the dots, the whatever he's given to me, and the first thing, right? Like I said, the dot is what matters. So if not stack, continue. Now why continue? Well, because if you are, let's say, in your home directory, you are in root, right? You do dot from there, but you can only go back to your root, right? Doesn't really make sense. It will just bounce you back wherever you were. So just continue on that and just ignore it essentially, right? But if not, pop, right? Like I said, you're just going back one, so just pop. Now, otherwise, there's 2 parts. So if it is an empty string, that means it's a multi-slash, right? Or if it is a singular dot, right? A singular dot, like I said, stay in the directory, that means really pretty much nothing. Just continue. If not, then it's a file name, right? That's what they said. Anything that's not a dot, that's not a slash, is just going to be a file name. Multi-dots are also a file name. So that's pretty much it. At the end, if you don't have anything, right, you don't have anything at all, then just return an empty this thing, your root, right? Otherwise, add a slash and then join your contents from the stack with a separator. That's pretty much it. Very simple question, just a bit of a syntactic part. Evaluate RPN. Okay, this question is also really easy. I'll show the pattern and then you should try it out yourself first, right? Uses the same structure just like we did before. Very, like, the best way I can show it to you right now. Let's consider the example that they've given. Okay, this value is to 9, right? That's our target. How do we do this? How do we reach here? Okay, for the people that didn't understand the question description, this is just going to be a very simple overview. We encountered 2, we encountered 1, right? As long as we are encountering operands being the x and the y, and the operators being in the middle, right? X and y are the operands, so 2 and 1 are the operands in this case. The operator is a plus symbol. Whenever we see an operand, we just like store it, right? But whenever we see an operator, we immediately have to take out two operands in particular, and do the operation on them. So 2 plus 1 in this case, 3, right? Now once we're done with the calculation, we also add it back into the structure, and it looks like this. Now it's an operand, that's an operand, we see an operator. What do? Take it out again, 9. and look at that, both of them are equal, right? So what do? Whenever we see an operator, we take out the previous two, right? And what helps us take out the previous two? What helps us take out the previous element? A stack, right? So try and implement this by yourself. I'm going ahead with the code now because it's very simple actually. It's just a bit lengthy. I'll make it a set. I mean, I don't think it really matters. It's just 4 elements, so it would still be a constant check. But just for the sake of it, I'll make it a set, right? Okay. Now for T in tokens, keep in mind, right, everything that's given to us is a string. That's why we convert them to integers as soon as we get it. And you know, we've been guaranteed that we will always get 2 operands before they give us an operator, so that's fine. And you can just safely pop, get your operator 2, get your operator 1. Simple as that. Okay, I mean, I won't be continuing it for all of the operations, but it's pretty much just this. If you see this, then if you see minus, then you do op1 minus op2. If you see star, op1 star op2, you see slash, you do op1 op2, and that's right. And you just do this, don't do any floating point. I mean, don't do I've converted it to an int already, so it will give us an integer division. That's not an issue if you follow the code. But if you don't do that, make sure to convert this into an integer at least, so that chunk gets towards 0. That's what they want, right? But if it's not an operator, then we can just safely add it. At the end, just return int stack 0, because I will have your last element, like I said, right? 9 will be in your stack at the very end. That's pretty much it for this question, right? Pretty simple, very straightforward. Now the main question, the main part of today's topic, largest rectangle in histogram. Go over like a very simple illustration actually. How do we go about deciding when to do what in this question, right? Let's consider this example first. 2 and 1. When you want to calculate an area of a certain shape, okay, what are you limited by? You're limited by the size, the dimensions of that shape, right? In this case, if you wanted to consider the maximum area, right, how can we go about it? You can take 2 by itself, right? Or you can take 1 1, combine that as 2 and get a block of 2, right? Those are the 2 valid ways, right? Both of them give you the same area. I mean, it's not going to be always like that, but both of them are giving you the same area in this question. But you there's like two, the main thing is there's 2 approaches to it, right? Either horizontally or vertically, right? And what is it limited by? It's limited by the fact that if you encounter something smaller than you, then you know that you're going to be limited by anything that comes after it, right? Because that's the extent that you can reach at. So if it is limiting, then we have to consider ourselves and consider the horizontal and the vertical and immediately do the calculations, right? But what if it's 1 5 6, right? Now you're no longer being limited, right? When you're going from 1 and 5, you're not being limited, you're getting a higher area, right? Same goes for 5 to 6, right? It's not really an issue. 1 will stay bounded to whatever it was, but 5 and 6, those are not bounded to 1, right? Now when 6 does encounter 2, we do have an issue, right? When we do encounter the 2, we're going to be limited by the 2. So what can we do? We can either take the vertical, or we can take the horizontal, right? In this case we can take 6, the whole vertical, right? That's gonna give us an area of 6. For 5, right? 5 saw that 6 was greater than it. It can merge itself over here and do a double of itself, right? In this case 5 would look something like this, right? Be able to go across the whole thing and give itself an area of 10, right? And in this question this is the answer, but it does sees that and doubles itself and gives the answer, right? So whenever we see something that's going to be limiting us, right, what we're doing is we're just immediately starting to check ourselves. How do we check ourselves? Well, by popping ourselves off of the stack, right? That's how we get these elements to do the calculation. In particular, this is actually a monotonic stack question. That means you have to like maintain a certain property in the stack. In this case, a strictly increasing one. You can look up the definition and stuff, but this is a bit more intuitive the other way around. Like, I don't want to talk about monotonic or whatever. I feel like it's a lot more intuitive just this way right now, but you should learn it. Like monotonic, you should learn it. It will help you with the other questions. Now, how do we determine how do we determine the fact that it's 10? Well, we were given 0, 2 over here, right? 1, 2, 3, 4. The gap between 5 and 2 at the point of popping is 4 minus 2, which is 2 times 5, which is 10, right? That's how I determined it in that point in time. So now that I've explained when do we pop, well, we pop when it's shorter, right? When it's smaller than us, okay? And the other thing that we can do, there's two conditions, right? One, popping, and two, the whole horizontal case, right? If you think about it logically, if you have one, right, and you have, let's say you have 10 million other rectangles over here, one, even though it is a limiting thing, if you merged everything with a 1 all the way up until 10 million, your area would come out to be 10 million, right? So it is not it's not smart to neglect the idea that there is a horizontal thing that could happen, right? 1 in this case. So how do we consider it? So when we saw that we popped from 2, right, what we can do is, since we considered 2 already, we will extend our 1 to this point, and we will remove the line that looks like that. So it will look something like this. 1 would now look like this. It would occupy index 0. So if we took a table, height, right, that's what it would look like, and it would just keep extending itself up until it reaches a certain index at which it shouldn't. Okay, this same thing goes for 2 as well. You know, it can extend itself all the way till here, and you can see that it gave itself 2, 2, 2. It gave itself 6, right? So that's pretty much it. So it's all about extending yourself as well, and doing knowing when to pop horizontal and popping. I write out the code now. It will be a lot more easier to understand this as well. On my stack, I'll be storing index and height. Okay, we'll make another variable here, start. We'll call that I. Now, why did I do I, by the way? Well, like I just explained, we can go all the way to the left, right? We can stretch ourselves to the left, and then we can consider that index as our starting index. Now, when we know when to pop, when the height that we're on, right, is greater than, so like the 6 is greater than 2, right? In this case, this would be 6, this would be 2. right? Up until then we can keep popping, but not so easy. You want to consider the height of them as well, right? When you pop, you want to, like I said, consider your own area as well. So answer in this case becomes a maximum between the answer that you have already. Height, in this case you could think of it as like 5 times I minus index. So 5 minus 2, 6 times 5 minus, sorry, 5 minus 5 times 2 and 6 times 1, right? And your start index would also, since you have taken it out, your start index would now expand all the way left up until that previous index point, right? And once you're done with all of that, all right, now obviously one won't get popped usually by this. Whatever is left over, right, from your stack, like let's consider every single area over here. Whenever we pop 6, 5, 5, 6, and then 2, 3, right, 3 would also be left over here. We would have 1 uncalculated, 2 uncalculated, 3 uncalculated, right? Only calculated when we popped. So we had 1, 2, 3, these are all uncalculated. We have to do some cleanup service on them because, like I said, if for some reason 1 to 10 million, right, is just 1, then you still need to consider it, right? So for IH in stack, now we're just doing cleanup, and this is where the thing comes in real handy. The idea of starting at starting at the leftmost value, you can do len height minus I. This way, when you do have your 1, right, when your 1 extends from here to here, 0 to 2, you would get this 2 minus length of heights, which I think is 2, 1, 5, 6, 2, 3, so 6 minus 2, right? 4, 1. Essentially, you can expand yourself here. And just return the answer because that would be the maximum at the end. And that's pretty much it for this question as well. And that's pretty much it for the entire tutorial today.